Hello, welcome to today's webinar, which is called How to Create Projects for Merbon SCADA in RcWare Vision. I am Michael, and I am here with my colleague John.
Hello, I'm Jan Vidin here.
And today we will cover basics of creating projects for Merbon SCADA in RcWare. Plus, we will show you the latest version of RcWare, which will be soon available on our website. And then we will show you how to create projects in RcWare effectively. So we will show you some functions which you can use when you copy some parts of your project. And then we will share our experience from technical support. Also, we will show you how to prevent or fix some of more frequent issues. And also, I'd like to remind you that it is possible to ask us whatever you need to know. So don't hesitate to write a comment in chat. So we will continue. And for the first, I'd like to show you what is Merbon SCADA. And you can see Merbon SCADA here. And there is some scheme of boiler room, which is just a showcase for you. And I will also show you the RcWare project, and then we will cover how to connect Merbon IDE project with RcWare, and then how to export it to Merbon SCADA. So we will create project from zero, and then show you how it's done on Merbon SCADA server. So as you can see, there is some technological scheme, and this scheme is created in RcWare Vision, which is this software. And this software is mainly, it is a SCADA software, which consists of table of data points, which you can see here. There are some data points. And also the second part of this program is editor, a scheme editor, where you can create your schemes for your technological process. In this example, I show you the basic project, which is Merbon SCADA demo project. And I can show you even a more complex project, just to show. We have Merbon sample project, which is available. And if you want to get this project, just write us on support .cz, and we will send you this project. As you can see, there is a lot of data points. And these data points are named in Czech language. If you want, you can just rename it to your, or you don't have to. And also I will show you this project exported in Merbon SCADA. Also there are other schemes. Because we are not connected to real PLC, you can see some communication error messages here, which are marked by this icon. We will not connect to real PLC. We will just connect to Merbon runtime to show you the basics of connection, how to connect project with PLC. And I would like to add that Merbon runtime it simulates PLC on laptop. Okay, so in the first phase, I'd like to show you what is important to understand in RcWare. I have two stations here, Merbon sample project RA1 and RA3. And in this case, I'd like to show you the basics and how to connect to your PLC in Merbon IDE. When you use some project for PLC, maybe it's better to show. Now we have the project opened in Merbon IDE, and here we can attach PLC by clicking on this. Look for UDP broadcast, but I need to turn Merbon runtime on. I'll just show you. You can see there is nothing to explain. And there we have Merbon runtime, so I will choose next. This is not needed in case of Merbon runtime, because in connection parameters there is a local host address, which is the Merbon runtime which is running on this laptop, so it's local host address. And now I will show you the project. You can see many block functions here. We have prepared several blocks for air conditioning. For example, I will show you this one. It's just a function block with inputs and outputs on the right side. On the left side are inputs. You can copy this part of program as many times you want. And we will focus in another phase of this webinar how to copy these parts of project and what you need to do in RcWare, how to change the address in RcWare for specific data points which are representing by the variables in Merbon IDE. My colleague will tell you more about this. Now I just show you the basics. And as we have PLC connected, now how it is connected in RcWare, the connection is established by this key. And you can see in the field of host, you can put your IP address or PLC, which is localhost. We use SSCP port 12346, and this login you can find here in section PLC connection parameters in Merbon IDE, parameters for connecting to PLC. And also I will deploy the solution to Merbon runtime. We want only program to be uploaded. Okay, so basically this environment is for creating programs and uploading them into the PLC. And since we have a program uploaded on PLC and we want to use SCADA, we need to create a project in RcWare, which is like the middle software between SCADA and Merbon IDE. Now we can turn the communication on. I will save changes. And now these data points should be refreshed. As you can see, system time is online, but another data points, they are marked by green color, so it means communication problem.
It was a different process station, RA3.
You're right, thanks. When you edit some data points in RcWare Vision, it is needed to stop communication because you can do some errors. Maybe John would tell you more about this.
So if we are editing an RcWare project, we have to stop the communication through the pause button above and unlock the data file to be able to edit, which is this one.
What about this message?
This is a funny warning, which everybody ignores, but that's not okay. We should always stop communication when we are editing or making some deep changes into the software, because when editing, the structure of the data file may vary, may change a bit. And then, as soon as we start the communication again, without stopping it first before the editing, it may happen that the values which are communicated from the runtime to this data table are funny, like hundreds of centigrades, temperature, and so on. And this can be prevented, this can be fixed by deleting a particular file, but this is what I will show you later. So now let's just keep the rule that before we edit the file, we stop the communication, which is the situation right now. So the communication is stopped and the file has been edited. So we now enter the new IP address into the communication definition line and start communication again.
But what about the previous PLC? Would it cause problems?
Most probably it will have a different IP address, but it will try to connect to the runtime. It won't match the variables, so there will be a communication error. We don't need to care about it now with the demo project, but of course later in reality, when you have two different PLCs, every PLC has to have its specific IP address defined here. Okay. So now let's start the communication and have a look at the RA3 PLC. So if we go down there, these data should be refreshed.
I can see
something's happening. And this means that we get the most recent data. Maybe there were some changes in the project and the data point don't match with their data point IDs. And this is also what we will see later. So now let's have a look at the overall picture, the presentation of the Merbon SCADA. And with this editing function, this is what we will fix in the second part of the webinar.
Okay, thank you, John. So in this phase, I'd like to show you SCADA, how to export this RcWare project to SCADA just in short. Because this is a new version of RcWare, I'd like to show you that when you have table of data points and your scheme, I'll press Ctrl plus S. It's a keyboard shortcut to this technological scheme menu. I will double click and I will get inside the scheme where I can also edit every object by pressing this icon. Also, it is good to remember that it's needed to stop communication. You can edit your objects, but in this scheme there are only images. There are not real objects like some rectangles or lines. These are only prepared images. Alright, so the second part, you need to export this project from RcWare to Merbon SCADA, which you do simply here. You will choose your station, for example this, and then the export is happening. We will show you how to export your projects more in depth later. Now when I export this project and I put localhost address here in the web, here in the section of web browser, you can pick your project which you have exported before. And because I have prepared these projects already, I can just simply switch between those projects. This is project SCADA demo, which is a simple version, and there we have more, how to say, difficult, complex things, project. Alright, so this is just to show you the basics. And now I'd like to invite John to another part of this webinar, which is creating Merbon SCADA project from the zero.
Let's suppose we have ready Merbon IDE, the Merbon Development Environment project. This was edited here in this software. And as soon as we have this ready and upload it into the PLC, part of these files which have been generated is also the list of variables which result from this project. So let's have a look at the project directory, the folder where we have all these files. And this is our main project folder with some files which relate to the project. And there is also a binary folder here. And in the bin folder, there are two files which contain the variable lists. Their file extensions are Vlist. So you can see one of them here and another one here. The Vlist is short for variable list, and the name of the PLC is here. Here in the project you can see the PLC name, which is PLC with not much fantasy, and another PLC, the same text string is here. So if we open the difference between those two files is just the coding of characters. So normally it doesn't matter if you use just Vlist or the UTF-8 Vlist. So if I open this with a text editor, I can see that this file contains just text. And it is actually a list of all these variables. There's a lot of them here. If I go down to the bottom, I can see that there is about 12,000 variables in the file. Okay, we won't need all of them, but let's just have a look what every line means. So the first one is the name of the project. The parts are divided by the semicolon characters. Another one is the name of the variable, which is also separated by the dollar signs here. The next one is the Boolean, is the data type. So it's Boolean for binary variables. It might be real for real variables, integer, byte, whatever you find there. And the next one is the index in memory, which is actually the variable ID. So under this number, we will find the variables later in the software. or in other words, the SCADA will find them in the PLC. This one is offset. So for the case of more complex variable structures like arrays or structures, under one ID, there may be more different variables. Like this one might be an ID of an array, while this one is the position of the variable in this array. So most of the variables are simple type variables, which means that the index is 0. There's only one position under this ID, and this is marked by this 0. This one is the variable length in bytes, so that the SCADA can see how many data it should read from the memory. So the real variables, for example, they have 4 bytes in the normal precision. If I have a Boolean variable, it mostly takes 1 byte because this is the least unit we can read. We cannot read individual bits, but we will read bytes. So one Boolean variable takes 1 byte here. If I have, let's say, some integer variable, let's have a look down there if we find something. For example, the alarm status. This is an integer variable, and it is 2 bytes long. This is what we can see here. So the last one is the name of the history block in case this variable is sampled as a history variable. So here up there we have the legend, the parent type family, that's history ID. So we don't need the insight of the file. We just need to know that there is something like this working for us here in this project folder, and we have to know where to find it, where to locate this file, which is what we need later. So this text file in the bin directory, this is actually our interface between the Merbon IDE, between the developing environment, and between the SCADA. So now we see that the stations have been exported. This was just for the demo. And now let's make another project from scratch. Yeah. RcWare Vision, which we can see here, this is actually our previous SCADA software. This was a single user environment. Now we use Merbon SCADA with its multi-user environment. And so far, the RcWare Vision is still used as an editor. This has some advantages because a lot of people are used to work with it. It's a simple program to operate. And what more, there is a big pool of already installed projects which may need to be converted into the new SCADA. So therefore, we use the old file formats, and for some time, this RcWare Vision will still be used as a project editor for the SCADA. So now, if I close all these projects here, because I may have opened more projects at a time. Okay, let's close all the windows. So this is my empty workspace, and here is where I will create my own new SCADA project for this Merbon IDE project for the PLC. So the task is, or the point is, to have these data in another program, in the SCADA program, in a nice platform for visualization and history trending and alarming and so on. So let's start with creating a new project. Here in settings, I create a new station. So that's the first point. Of course, I have to specify the station name. So it will be, for example, my project.
I'd like to add only that you would expect to create new station in a different bookmark here, but in RcWare it is created in settings, which can be quite
confusing.
Yeah.
Okay, so we set the whole things up, so we create a new project here. I can either just click OK and my project will be created, or maybe better, I can use an assistant, which will help me to configure the other project parameters. So why not to do that? Here I can edit again the station name. The SSCP protocol, this is the protocol we will use for communication with the PLCs. And this is a company specific but open communication protocol for the SCADA or another client to talk to the PLC. For example, the Merbon IDE also uses SSCP to talk to the PLCs. Merbon Visual, like your mobile application, OPC server, whatever, talks SSCP to communicate with the runtime or with the PLC. And SCADA will do the same. So we will use SSCP protocol. There is a list of many protocols here. Not all of them are supported with by Merbon SCADA, because this is the list of protocols which are implemented in the old RcWare software. So we will use now SSCP for Merbon PLCs or Soft PLC Link for the old generation PLCs in case you have any deployed. So SSCP will be our choice for Merbon PLCs. A logical channel is actually a socket in the RcWare or in the Merbon SCADA, which will be used for communication with a PLC. Logical channels are defined in the SCADA setup. I will show it later to you. You will pick any appropriate any of these which are appropriate for this profile. So for example, number 1, that's a good choice for us. So let's finish the wizard. It was not that difficult. And a new project opens with a predefined group and a definition file or definition data point for the SSCP protocol. This is what we know already. Michael showed this to you before. And if I open this project and double click this one, again, I can see the default IP address for communication, which is localhost. This will be the IP address of your PLC. The port, most probably we will keep this, user and password. For security reasons, it's highly advisable to change this one to some non-default value. Of course, to make your life easier for the tests, you will most probably keep these ones, these credentials to communicate with your PLCs. But then on the real side where your, let's say, know-how is deployed and you want to protect the technology from hackers, these username and passwords have to be also set up accordingly in the PLC. And this is done, as you may know, here in the configuration of the PLC. So we will use admin RW. This is the most powerful password for engineering. But for SCADA, also a full control access would do. This is that you can change values, read values, but you can't, for example, change configuration. This is what only the engineering user can do. For only monitoring, if you want to have a SCADA which is not allowed to do any harm to the PLC and you only want to read values, you can use the read-only user. So in this case, the PLC has this read-only user who is named read-only and the password is RW. Okay, so let's go back to RcWare. And the next point for the configuration of the communication from SCADA to the PLC is the slave ID. What's this? Well, in the Merbon PLC topology, the most of the connections are over TCP, which means the Ethernet network and the SSCP over TCP protocol. But this SSCP protocol can be routed to serial. So if we have more PLCs which are connected over a serial port, and then one PLC which acts as a router, it can route the RS485 line to Ethernet. And this means that all the PLCs are accessed through a single IP address of that of the router, but we have to tell between each other using the slave ID. So every PLC on a serial line would have another slave ID. If you know the Modbus topology, like Modbus RTU and Modbus TCP routing, so that's a similar issue. All of your, for example, energy meters have different addresses from 1 to 250, but the Modbus router only has a single IP address, and through this address and the slave ID, you access the individual meters. So in this very same way, you would access your PLCs, which are behind a single Ethernet connected PLC on an RS485 serial line. To make the long story short, normally if we only have a single PLC on an IP address, the slave ID will be 1. Okay, the proxy ID, this is not an issue now. And these communication parameters, they are used to optimize your data flow. So the refresh rate means how fast the telegrams will be sent from the SCADA to PLC to ask for values or to command the PLC. 1 second is not bad for the beginning, so we can see that something is happening. Of course, if you have a big building and PLC full of variables, you would like to speed up the communication as much as possible. So in this case, the refresh rate might be, for example, 100 milliseconds. It's not a good idea to make this even shorter, like 10 milliseconds or so, because the Windows or the server won't be able to process these requests any faster than this. So I think that 100 or 200-300 milliseconds are okay. And the timeout, this is the time for the SCADA to wait until there's a response. So if the SCADA sends a packet and the PLC doesn't respond within 20 seconds, according to the settings here, this is evaluated as a communication problem. In other words, the SCADA waits for 20 seconds for the answer from the PLC to come back. So maybe 20 seconds is a long time. In fact, this is not that important for our purpose. This one, the group read, this is more important. Because if we don't check this, then every single variable is read using a separate telegram, a separate request, a separate TCP packet, which means that if we have 10,000 variables in the data list, it may take a lot of time to communicate all of them. And our communication would not be that fast. That's what we don't want to do. So we use group read, which means that within a single TCP request, there will be a command to get back the value from the PLC for example, 20 or 50 variables at a time, which will speed up the communication in a very massive manner. But on the other hand, if one of these variables in the group is not found, then the whole group is corrupted and you won't get any of these. Even if you have 90 or 25 variables okay, and one is not present in the PLC, then the whole packet is not correct. So if there is problem with the communication, it's advised to uncheck this group read first, let all the variables to update one by one in a separate manner, and you will see which one is not communicating. Then this has to be fixed, and then you can switch on the group read again, which means that you optimize your communication flow and you are able to analyze which variable is making problems. So we've set up this communication somehow. Let's click OK. Here is the communication channel down there. So this is what we selected in the wizard. But now, how to define these communication channels? This is again, not surprisingly, in the settings menu. And when we pick PC resources here, we see that there is a lot of things to set up here. But we will focus on ports. Here in the port settings, we can define up to 200 or 400 even, 400 different channels, which means that the SCADA is able to work with 400 PCs at a time. And some of them may be configured as software drivers. So this is what we need for the Merbon PLC to connect to, and for the soft PLCs as well. Other options are also a bit old-fashioned, like serial line for direct connection over a RS-232 port, which is not used anymore, modem for a dial-up connection, and the network adapter, which is something which we don't want to know anything about. So the result is that the software drivers general device, that's what's necessary to do here. If we have a channel which is not defined as a software driver and we try to use it, like here, there should be a problem later in the communication because the communication channel won't be recognized and data cannot flow from SCADA to the outside world. So I will stick to the setting which makes sense and use the communication channel of 1. All right, so we have the header here, maybe something which is called a group, and the data point, which is defining or specifying the communication. And all these data points are also easy to see here in the left-hand pane, which is called a tree, a project tree. In the tree structure, we can add and organize the variables and sort them by those separators. So one of the separators is this one, also called a technology group, which you can see down there. Another one is a group of data points, and then we have also the data points themselves. So if I want to add more data points, maybe I should do some organization here, like adding, for example, a group separator, because this one is, first group is defining the communication. So I can call it like that, then go to the bottom of the data file, which contains 3 lines now, and using the insert key or picking here the edit and new data point, I can insert another line in this table. So now it will be a header or group name. With the assistant, there's not much to choose from. So I will just give this group a name, like my data points. And these may be, for example, a part of the technology, like air handling unit or boiler room, heating circuit, and so on. We can also use these technology group separators here, like boiler room, and then the small group names like boiler control, heating circuit 1, domestic hot water, and so on. It depends. These headers and separators can be edited, deleted, and moved anytime.
You can also change the color of your.
You can also change the color here, but it doesn't make much sense for the beginning. It's just to tune your project up a bit in the end, maybe. Yeah, to make it look nice. So back to my data points group. Now it's the most critical point. I want to insert a value and link it with my Merbon IDE project value. So we will use the insert key again. There are 2 ways how to insert the values actually. One of them is in a manual way, which is picking every data point one by one or copying it or make some manual addressing. This is detailed, but not very effective, not very efficient, and not very fast. Maybe the better way for the beginning is to make a mass import and bring all the data points we need, or maybe a group of data points we need, to the project in one step. So let's do this. I go back, and this inserting one by one we will show later. So now, for this import, we have a dedicated function here. It's found down here in the import-export tab. And as you can see, there's a lot of ways to import data. Most of them, again, are for the RcWare Vision SCADA. What we will use now is just this very button, Merbon IDE import, create data point from the Vlist file. Okay, the Vlist file, this is what we saw before. And now we will pick the file using this dialog and select the data points to import. So let's start from the top to the bottom. Here I have the recently used data point lists. Okay, this is empty. So I will pick one here. Let me just know where the project is.
Would you like to use Merbon sample project
array tree, which is what's in the Merbon runtime. Thank you. So as I showed you in the beginning, we have to go to the bin directory, and then there are those 2 Vlist files. We use either of them, doesn't matter. And now we can see the names here. This is the data point name. As you can see, it's pretty long. It has more than 30 characters. This is because our project name is relatively large, Merbon sample project array tree, then a hardware data point from a particular device, and this is the variable name in the end here. Okay, If we import the data points into RcWare Vision, into this editor, we will see that the data point name length is limited to 31 characters, which means that in this case, most of the data points will be named like Merbon sample project, RI3, or whatever, and then the rest, which is of utmost importance for us here, which is the real name of the data point or of the variable. This will not be visible anymore because it's cut off. So what we need to make the data point name rule, and we take the whole name part from right, and it will just pick the part which is separated by the point here, by the dot. So we will not start with the Merbon sample project array3, but with the name of the data point which is here in the right part. Okay. Then what we also can see is our other variable properties like variable type, variable ID, then the offset and length of the variable. This is actually what we saw in the Vlist file in a text form. Okay. So let's pick some variables. When we are doing the import, we have to specify the data point type as which the variable has to be imported. Let's go one step back. So if I cancel the import, I hope it works for me, and try to edit or insert a data point on a manual basis, I can see that there are some data point types here up there. So one of them is analog input. This is clear. SCADA is reading a value as an analog value, as a real value. Then the output is that we also can control the data point from SCADA. It may not be, or most probably it is not, a physical PLC output. No, it's like a set point, for example, because this is the output for SCADA. We want to control the set point from SCADA to the PLC. So it hasn't just to be an input, it has to be an output because we need to write values from SCADA to the PLC. So this input and output naming is related to the SCADA, not to the PLC. The same is for analog input, for digital input and digital output. So digital input will be, for example, a thermostat status, on, off, or switch state. Digital output, this is the data points to control, like enable HVAC plant, disable HVAC plant. Time program, okay, this is a more complex structure. This brings us to the editor of a weekly scheduler. We will see it also later. And the controller time, that's a real time of the PLC controller. This is what you could see in the demo project. And it is used just to check in the SCADA that your PLC is up to date with the RTC, with the time. The next three ones are what we saw already, the group separators and the definition with the key for the communication drives. And the last one is a script data point. A script data point is not necessarily linked to a physical data point in a PLC, to a variable. It's just a container for text, for a script, which may execute some functionality in the SCADA. So this is what we will use for alarming later. Okay, so now we see that we have 4 or 5 basic data point types, and we will use them also here in the automatic import. So every data point which we need to import has to be selected as a import as. So if I have, for example, some temperatures and pressures, which are these data points, and I'm recognizing them by the name, by the variable name, I can use the control key plus left mouse button to pick the data points, or I can use the shift button and down arrow key to select more data points at a time, like this one. So here I have just selected several data points, and now I have to import them as, or to set if it's a analog input, analog output, or whatever. Here it's a real value, so it will be an analog value, and because these are measured values, they will be analog inputs. So either I will select it as analog inputs here, and we can see that it's named here already, import as analog input. Or I can just mark the data points like before and press the space bar until I get the correct variable type. So digital inputs, digital outputs with buttons, analog inputs to read values, analog outputs for controlling or setup of an analog value, time program in case it would be a time program, which is not, time of the PLC, like a real-time format, and cell. So the cell is a special data point type which copies the data point type from what I selected in the project. So this is a specific thing, very useful for alarming, for example. So now, to keep the thing simple, I will use the temperatures and pressures to import as analog inputs. Okay. The last thing is to pick the correct communication channel. Like this is the first channel because this is what I selected here in the SSCP protocol definition up there. Of course, I can import more data points or more data point types at a time. These are already marked as analog inputs. And I can go down there and pick another group of data points like digital inputs and make digital inputs out of them, like this. Then, for example, I have some set point. So let's find the set point. This will be digital output because it's to enable quick mode. And now let's have a analog output. Like I have these three set points. And there will be analog outputs. Maybe I can pick also the PLC time if I'm able to find it here, which is not the case right now. This must be done on a manual basis, I think. Do we have the time scheduler here? Time?
I think yes, it should be part of this project.
This one? Let's try it. Time program. And now I will just import all the variables into my project. To have a simple or easier selection of data points, I can filter here with filters, like according to data point name. So if I want to select all the temperatures, I do it like this. This means that most of the variables here, maybe if I have better selection criteria, I could mark all the data points here at once, like picking all of them and make analog inputs out of them.
And when you mark one data point and press shift and mark another data point, yeah, nice.
Yeah, so it makes the whole range between them. So this is how I can actually very efficiently mark all of them, like pick one, then go down to the bottom and click the other one. But this means that all of them would be imported as the same type, because this is just used for the selection of the type of the data point. So now I have most of the types here. I also defined the correct communication channel. And now I just click the import. It takes some time, and I have the variables here, but not all of them. Most of them are missing. So let's go again to the importer. Maybe with the other demo, I just unchecked all the other ones. Let's go back to the digital inputs, like here. Importing may take some time. Now I have the data points. Okay, I didn't pick the naming, so all of the data points have the same name, but the register address is here, so I can tell according to the name here. Most probably for the users, I will need to change the names so that they understand it easily. So here, for example, this is not the supply temperature of air handling unit 2, and this is what I can do here. Like this. So that's an easy way for me how to change all these data points and assign them some reasonable names or easy to read names. So once I have this ready, I can just log the data file again, check, and start communication. And it should be white in a while. Just let's restart the runtime because as an unlicensed software, it has a limited lifespan. So it just runs for 20 minutes with communication and then stops. So here we can see that our project is already communicating, and here we can see the update time of the individual data points. Every timestamp means that the data point has been updated. In the upper bar here, we can see that this is the most recent update time, and this is the, let's say, less recent update time. Here in this case, we have 10 data points or so. So all of them are read within one group. I can also show you how it looks like if we only don't use the group reading. So we use individual reading. The whole communication will be not that fast, and every data point will be updated in a single request. Here you can see how it follows. So it's not that all the data points are refreshed in one moment, but they are refreshed one after another. If we have several hundreds or thousands of data points, this is not very good. So let's try to use this group functionality, like here, group read. And now the whole of the group will be updated as one. So now all the data points are updated correctly. Most of them are in one group, and this seems to be in another group because it has a different time of update. Well, now before we start to create the graphics for SCADA, it's always good to have this list of data points as complete and tuned up as possible. Now let's have a look for different data types. Mm-hmm. Now we can see that there are some temperatures. Of course, we don't have real temperatures here because this is a sample project running on a PC. So I will just expand my project down here by another data point type. It will be an analog control. So let me find the real set point. Hopefully this one will be okay. Analog output. Import. Let's start the project again. I can change the value here, and if I want to enter another value here, I just click in it and enter the new value. So we will see later how to change the individual properties of the data points. But now let's have a look at the time schedule. Here I can also use the insert key to insert the real data point in the same way as we saw for the technology group header and definition for the communication drivers. So if I insert a time program here and use the assistant, so it will be my schedule data point. These will be the values for on and off. And I also have to load the Vlist file again. Oh, this is that one, Merbon Sample Project RI3. And this is the easier way how to pick the data points.
Are you looking for set point?
For the time scheduler. For the time scheduler, and should be somewhere here. I should be able to set up according to the name.
What is the name of the scheduler?
Time program, and this one of base.
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 And here it is.
Okay.
The whole file.
So this will be my time scheduler data point, right?
Yeah, it is the whole file or the TPG value.
TPG value here. Yeah, seems better
Yes.
right now. TPG value. Okay. So again, if I save my project, start the communication, and open, I should be able to make some structure here for the time scheduler. And if I load this to the PLC, it's already on because I'm here right now somewhere in the middle of Thursday, and it's a state where it should be on. If I use this one for off again, I have to allow edit first. Then the status goes to off. So this is how it works. It's just necessary to know which data point from the Vlist should be assigned to this schedule data point. It is quite easily to see in the Merbon sample project, which is also where I took this value from. So what next? Digital output. So a digital output, that's maybe the last point I will talk about right now. And this is something like analog value, but digital. Digital means either on-off or a multi-state value. In the simple example, we will use this digital output again for some data point which we need to change. I wonder if I find some value which can be changed here. Maybe here some enable, but all of them are inputs and outputs. So not very much values here are just changeable, right?
Is there any other function block maybe?
Maybe this one, function block control. And all of these are inputs. So again, they depend on other variables. And what I need is a global variable which I can change.
So we can
So
find
maybe here the reset, again, reset software reset. That's a good example. Yeah, reset underline software. So that's what I will use. So I will just pick the digital output button, and again I can use the assistant. I give it a name. Again, assign the data point values. For 1, it will be 1. It will be on, and for 0, it will be off. I can also have a multi-state data point. If I have, for example, a day, night, and standby, I can have 3 states and 3 different values, not only binary, but also multi-state. So let's stick to these 2 first, and then we will see the rest. And the name of the data point was reset software. So it was maybe somewhere here under R, reset software. Double click, and I can see that the communication parameters were copied to these variable properties here. Channel 1, okay. Software reset. So again, if I log the project, save it, and start the communication, It's updated immediately. And if I set this software reset to on, I should be able to control this value. But it seems that the software reset is somewhere written to. So if I quick find this variable, I see that it's a time-based function. Okay. So it seems that it's read and written at the same time. So it has some now it's on, and it will go to off after several seconds automatically. This is because of this monostable structure. So again, the software data point, it's not a typical data point. It will reset on its own, but I can do it also on a manual basis like here. So I can switch between on and off to control, for example, a air handling unit or a heating circuit. If I have a look inside of the data point, like double clicking it, I see the individual properties of the data point object. The first one, there are actually 16 properties in total, 16 possible properties in total, which are here in a form of a table. The first property on the line named 0, this is the red value from the PLC. Okay, we have some value here, and this is the data address. If I double click this, I can assign another data point, another Merbon IDE or Merbon data point from the PLC to this line, to this object. Normally, it's used just to check if your data point is correct. If there are some changes in the software, you can easily fix it here. This is the red value, the value which is communicated from the PLC, and we can also scale it a bit, which means that this is typical for different protocols than SSCP, because the SSCP protocols uses for analog values the real data type, which gives you the correct value right from the bottom to the SCADA. But in case we integrate, for example, a Modbus value, or we need to scale this value for certain reasons, we can do it here. We have a two-point linear function here with the low and high measured and low and high real. So if I, for example, need to multiply this value by 10, I would say, okay, high measured is 1, but high real is 10, which means that I will have down at the bottom 2000 or minus 2469 degrees. The alarm limits, they are not used here mostly, but you can also introduce soft alarms for an analog value, and if the value goes above or below this limit, this lower and upper alarm limits, these exceeding of the values is indicated as a pop-up window optionally. Normally this is not done. You can do it if you want to monitor an alarm directly in SCADA. But in building controls, we mostly use alarms which are initiated down in the PLCs and have a multi-state form, like they can be acknowledged, reset, and so on. So this is just maybe to enhance the possibilities of the SCADA. Next to the last point is here the hysteresis, which is used for going back from alarm states to normal. And here down at the bottom, there is a resulting value, which is then displayed in SCADA, the unit, which also can be changed. It's actually a text array, so you can write anything you want, like degree Kelvin or whatever. But I will leave the centigrades here. And this one, the second parameter, is the number of decimals. So if I use, for example, 2, I have this resulting value here. Normally, we use mostly 1 for analog values. like this. So, okay, we see the first question.
And the question is, can you show a case where there are more PLCs, one in each floor maybe?
Of course. This is done by the first thing we have to do is the definition of more channels, or to check if you have more channels, because every PLC will need a separate channel for its communication. So in this layout or in this setup, I have 14 channels predefined, and this means that I can communicate with up to 14 PLCs, not even in a single project. I can have more projects, more data tables running at the same time. For example, if I open another data project like Merbon sample project, it seems to contain two PLCs. One of them is RA1, the other is RA3. So this one, the first one, is using channel 1, which we can see here. The second one is using channel 2. So now, if I want to have the communication with the Merbon sample project and my project at the same time, I have to use a different channel number than this one, because I have channel 1, and here in the sample project there was also channel 1, and this will lead to a conflict. So to be able to use more PLCs at a time, every PLC, even when they are in different projects, they have to use separate channels. So if I don't have any other projects than my project, I will just use channels 1, 2, and so on. So this was the definition for the first PLC, and now I need the definition for the second PLC. This will be more or less similar. So what I can do is to take use of what I've already engineered and just copy the data points to another part, or to another section. And I will do it like this. I will copy these 3 data points, or tag these data points. I will tag it using the T key. Then Control C to copy, like here, and then Control V. But if I insert the data points, I must be at the target destination. So I will go down and click Control V, and now I have the copy of the same set of data points as here. To untag the data points here, or to remove the green arrows here, the easiest way is to use the Control U, untag all. So now I need to change the channel number here. So I go to this data point. Here I have to enter the correct IP address of the second PLC, like this. And change the communication channel to another number, which I just make up according to the list of 3 channels from the settings and PC resources
Ports.
from the ports, right, from this table. Yeah. If I'm already occupied all the channels here, I can add more of them, like 15, and pick the 15th channel as software drivers again. If I want to make more channels at once, I can do it like this and click here, and they are all listed as software drivers. In fact, I could have all the 400 drivers set as software drivers general device by default, but it would only allocate resources in a PC, in the SCADA server, and this is not necessary. So why not to optimize the channel list according to the number of really used PLCs? Mostly about 10-15 is okay for a middle-sized SCADA, but if you need, for example, a drugstore chain or supermarkets, banks, or whatever, which have several hundreds of units or branches, you may have up to 400 channels here. But of course, this is more demanding for the communication. In fact, with the modern hardware, this is not any problem. So actually, it doesn't matter how many channels you assign here. It's only good to know that every channel is a communication link to a separate PLC, even if they are in different projects. So here I set up the channel 2, and now if I want to, what I also can do is to edit the text accordingly, and or I can change it here, like this. And here, if I import the data points, again I can do it here in the import dialog. These will be digital inputs, like this, and the communication channel should be 2. So when I import these data points, they will be part of the channel 2, which is also easy to see here in the register address in the table as soon as the import follows. Okay, so here you can see that the channel definition was for channel 2 and the data points are also for channel 2. So now if I start communication and there would be a PLC available on this IP address, I would have 2 different communication channels talking to 2 PLCs. And another PLC, like PLC number 3, this is the same story. So you can have more PLCs in one project, and of course you can run more projects concurrently at the same operating station, at the same SCADA server or RcWare Vision. If you want to run your projects automatically after program start, you can do it here. You just select from the list of projects the stations which should go online automatically after you start your RcWare. Normally, you don't use it because the RcWare is used just as an editor. And anyway, if it's an unlicensed version, as you can see here in the upper bar, you only have 20 minutes limit for communication. So you can check, as we did here, if your project is working properly, if the communication is okay. But then you will export the values to SCADA anyway. But in case you would use a licensed program as a main monitoring software, it's sometimes useful to select one or more projects here. Like if I want another project, like test. So after I start up the software, my project and the test project will start communication automatically. And I have to use parameters and click OK, but I will cancel it right now. So this is how to use 2 different PLC or connection to 2 different PLCs within one data point table. After I close it down and save the project and open it again, my project, there should be also this structure here in the, what I can do, divide the project better into parts. I can also copy these separators, like Control C, Control V. I will have my PLC in the second floor.
What about this addressing? Is it possible?
This addressing. This is kind of the RC address. This is also an interesting thing because as soon as you insert a data point into a RcWare project like this in the table, the data point is addressed according to this scheme. It's a 3-position address. It's like that one, and every address has to be unique. It's like order in the table. Of course, if I put 335 here, it works for me anyway. Sometimes it may be useful to use a certain system in this addressing, because what we can do is to copy the data points or readdress them in a mass way, so more data points at a time. It is quite useful if you have, for example, 10 air handling units. All of them are of the same layout, and you have a single SCADA picture, like here, you have a single graphics for all of them, and you want to copy it and have an easy way of readdressing. So if you are lucky enough to keep the same addressing scheme across multiple link units, just by changing, for example, the first name here, and this also can be done on a mass scale, like marking of multiple data points here. This can be done by pressing F5 or F6. So F6 marks or tags the complete technology group, and F5 marks the complete group. And here I can use for mass editing also the group functions. So the group functions are a very powerful way how to edit more data points at a time. It also can be dangerous. So if you use it, just be careful what you do. If you take more data points and click Ctrl G, there is a group function dialog which opens. Communication maybe. No, this is here. So if I want to change the technology group number for all the data points which are tagged here, here I have 1 first. So I will use 2, why not? And if I click on set, all the data points are readdressed. And now I have 2 link units. One of them is starting with 1 and the other with 2. And then if I go to the planned scheme, you can see that you can also readdress the assigned data points just by changing a single value. So this means that you have, for example, 20 data points in a handling unit, but the readdressing is very easy because you only change one position in their address.
And is it possible to readdress data points in RcWare according to Merbon IDE address?
According to Merbon IDE address, according to the to the Vlist variable,
like ComUID and so on,
like this one. Yeah, because it may happen that once you do this engineering, like assigning the data or picking the data points from the table and assigning them these values, these com IDs, then if you recompile your software, in other words, it's not just by recompiling, but if you have the Merbon IDE and make some massive changes, like delete a variable and then insert it again under the same name, or if you change the variable type, which means that it's real rather than integer as it used to be before, it has a different length. So this means that the memory layout for the variables will change. And this also means that these parameters, like the variable ID and the offset and length, may be different. And as a consequence, some data points which are here may not work properly. So now how to fix that problem? Or either you can pick every data point one by one, which means that you open the new Vlist file after the compilation and select the variable which you need and double click. And you can see that if I pick another variable, this value changes. So this means that I'm assigning another PLC variable to this SCADA object or data point table object. Okay, this is a rather tiresome task because you have to check all the variables which are non-communicating or not communicating properly, and you can also make some other mistakes here. So it's always better to use some automatic functions, which means that you just take all the data points which you need to refresh with the new Vlist file. Press Ctrl G for group functions, which also may take some time here. And here you can actually add a lot of different properties of every data point for different communication protocols. Now we use the SSCP communication, so we use this tab. And either you can set the com ID for all the data points on a hard basis, but this is not what we want to do.
And John, please, can you tell us what the com UID means?
Okay, the com UID, this is actually this value, and this is the address of the data point of a variable in the PLC memory. In other words, this means that every data point or every variable in the PLC, here we have different variables. One of them is bool, this one is real, for example. Every variable has a image here in the Vlist file or some definition. So that's actually a address in the memory. This one is offset. In case of some more complex structures like array, all the members of the array, they have the same address, but like here,
ID.
yes, this is the com ID. This is the time scheduler array, for example. And you can see that the com ID is the same for all the members of the array, but the offset is different. These offsets are different. And this is the length in bytes. So an integer variable has a length of 2 bytes. A long integer here has 8 bytes. A real variable has 4 bytes, and so on. So now back to this mass changes. Here I can update from file. So to update, I just check this one because I want only this function, not all the other functions, but just this one. And here I have to select most recent or the actual Vlist file. So if I do,
And also I'd like to add one point that the first option, you can set com UID manually, but it does not make sense because you don't want to have all the data points which you have selected with the same com UID. Like John told, it is a memory address, this com UID, so you don't have to keep all the data points with the same address.
Most of the items here don't make sense for normal work. They are just, let's say, servicing tools. But this one may be useful. So I have the most up-to-date Vlist here from the last compilation of Merbon IDE. And I will update the data points from file. I can also specify that if the variables has been deleted in the meantime and cannot be found according to its text in the Vlist anymore, its com UID can be set to 0 just for me to see that there is a problem there. Okay, so let's do it. It's no big issue. And now if I click on set, here the variables are updated. Okay, there was no change, so we have no problem here, and the IDs are the same as before. But this may be useful if you experience problems during engineering, so that your data point table works on Monday and doesn't work on Wednesday. So I think that in that case, this update using the group function. So again, edit group function, Control G. And in the SSCP driver properties, we will update from file. So let's pick the update from file function, and using the most recent Vlist file, we can set the new variable IDs here. Okay. Well, so this was the two PLC issue together with some renaming thing and manual changes of parameters.
And can you also please show us how to rename the group of data points?
How to rename all the data points at once. Okay, so we will specify let's uncheck all the data points and or tag using F5, for example, all of them. So if I want to change array 3 to array 2, for example, I can again use the group functions for this set of variables. And this can be done in the replace string in name function here. So if I replace array 3 to array 1, and click on Set. You can see that the renaming has taken place, and this might be good if you want to copy and change the data point texts, like delete this Merbon sample project, replace it by an empty string, for example, and use some other means of mass renaming. So that's how to edit this table. But in the end, your table should look somehow like this. You will have some texts which do make sense for you in your native language, because this is also what the users, the end users, will see at some times, like in the history graphs, for example, or in the SCADA data point properties. What now?
I have one more question. You showed us how to rename the group of data points, and now please, can you show us how to change specific interface in group?
In a group, okay. Some of the parameters here in this table. So we were presenting this data point as an object with the properties or interfaces rather than properties. And every interface has some other parameters. So one of them is, for example, here unit, which is now in degrees Celsius. If I am on an US market and want to change this into Fahrenheit, for example, this is just a text. It doesn't influence the value. I would have to make some recalculation here. But okay, let's suppose that it's coming from the PLC in Fahrenheit, and I just want to change this. Okay, I can do it several times, like 10 times or 100 times in my project, but this is not very efficient. So maybe the better way is just to pick all the data points or tag all the data points I want to change. And let me jump into this data point again. Note, please, that it's on line 15 or
It is the
interface 15 and parameter 1. So in this intersection of these two items, we can find the value which we want to change. Remember again, property 15, parameter 1. And now I go to function, interface number 15.
It's right away in this tab, DP inputs, outputs.
Yeah, it's in the DP inputs, outputs tab. So on the last interface, like number 15, I would like to change the parameter 1 to text. This will be Fahrenheit. And set. And now it changes automatically for all the data points involved. Okay, this one is very easy to understand. It may be used for the recalculations like alarm limits, low measured, high measured, low real, high real, whatever you want. Of course, there is a lot of things to destroy potentially. For example, if I go back to the group function again, interface number 0 and the driver, for example. So
the address, right?
Or the DB address, replace trinket name, this is fun. There might be a lot of harm done here, so please think carefully of what you are doing here. Maybe now it's a good time just to have a look in the file structure of the project and tell you something about backup and safety, kind of. Where the RcWare is installed is the C, either apps or directly RcWare folder, and all of your projects are in the data file directory. So here I can see the project names which I copied or inserted or created or whatever. So in every project folder, there is at least 2 or 3 files. One of them is the DTW. So that's the database itself. That's this table, which we have been editing since the very morning. And this is the most important file. You can see that mostly this kind of file has some bigger length than all the other files because it contains a lot of data. And another Another issue is that it has the very same name as the project folder. It must have the very same name. So this is Merbon SCADA demo, and this is Merbon SCADA demo DTW. This was test DTW, my project DTW. So if you copy and save this project, this file, you're on a safe side and you have actually the complete table backup somewhere. Of course, it's always better to copy or backup the whole project. If you just zip it like this, send to a zip file, you will see that it's not a big issue. It's 200 kilobytes, Merbon SCADA demo. Here, well, it's also not so big. But this sample project, for example, it has about 17 megabytes, which is also not so bad. You can do it using a RAR file. And this is just that if you have a 17 mega project, then the result is just 2.5. So the compression ratio is very high, and it's no problem to make a backup like this, and you are on a safe side. So back to this project structure. This DTW is the data file with the data table, and this is the backup file which is created automatically. If you save, or if you click this save icon here, the old version is renamed to backup and the new version is saved here into the DTW. So there is a kind of a backup automatically. You can see that I added some data points, so the actual version is bigger than the old version. There is a kind of automatic backup system here. One of the reasons that the data is destroyed is that you are trying to edit a running project. This is what I said at the very beginning, and I say it again. So if I save a project, start the communication, and then unlock the running project, I get a warning. It's recommended to close all windows and stop the communication before you start to edit something. But hardly anybody notices this. Everybody says, okay, and let's do the editing. But if you edit a running project, you may damage the index file. I will stop the communication just to be on the safe side. Let's have a look here back into the project folder. And this DTWX, the X is for index. So this means that there is an index file which is generated automatically at the program start. So if there's a inconsistency between the main project table and this index file, the references for the data points may be corrupted. So in this case, it's good just to shut down the RcWare, delete this project, just send it to the trash bin, and start the RcWare again. And a new index file will be generated at the program start, and your database will be referenced or indexed properly. So that's what you can do to avoid problems like funny values here. If you, for example, get a temperature of 10,000 degrees, this might be due to the corrupted index file. So let's smash it away and start a new one, and this will be generated automatically.
The other question is, if you engineer the PLC, make changes, etc., does the structure of the memory changes?
Well, it may change, and this is actually why we use these COM IDs. Because if we engineer the PLC, every inserting of a new variable or of a new function block or whatever fills the memory with data or with the position where the data will be stored. And the memory, of course, has some structure. If we have some variable which is in the middle of the memory and we change the variable type, like from integer to real, which means that it has 4 bytes rather than 2 bytes, because the integer has 2 bytes, and if we change it to real, it has 4 bytes. So we need to place for another 2 bytes. This means that we have to rearrange the memory somehow, and take this variable and put it to the end of the list, for example, to get a continuous 4-byte space, which may result in changes in these COM IDs. So if you make one version of your project, your COM IDs will be like this. And if you make another version of your project, your COM IDs might be different. This is not the rule of thumb. It may be or may not be different. If you just add more variables, this COM ID is increasing and the variables are put on the end of the table, and it's okay. And the old variables just keep their COM IDs and you cannot see any difference. But if you make some massive changes, then some of the COM IDs may vary or be different. And this will also spoil the bindings between the SCADA table and this software structure, which is in the PLC. So the structure of the memory may change, but if it influences the data point table here, it can be fixed by tagging all the data points by Control T, tag all data points, then edit the group functions, Control G, and going to the SSCP driver properties and update the whole set of variables from the new Vlist file like this. Set and finished. So it's a matter of 10 seconds and your database or table of data points in the SCADA project is up to date again. So this is no big issue, can be fixed like that. Just we have to know that and be aware of the fact that sometimes if we make massive changes in the data types in the PLC software, these kind of inconsistency may occur.
Can you show us how to create basic alarms like digital?
Maybe we can just have a few words about alarming here. Let's pick an alarm block and put it here into this structure. This is in the HVAC, I think. No, basic digital specials. Alarm memory. Single alarm memory with delay. So this is what we use as an alarm block. It has several inputs and outputs. Not all of them must be used at all times. We can see that most important is the in pin, which is this one. And if this is going to true, this means that there is an alarm condition appearing. So this is the reason to raise alarm. The other inputs are priority. This is for backnet, not necessary now, and we can just keep it in by making the input invisible. Then delay. This is the native delay from the raising edge of the input and the real launching of the alarm. So this is just that you don't have to have another block in front of this input. Okay, 30 seconds is okay for the most of the applications like HVAC units, fan control, flooding of a heat plant, and so on, pump checking, everything. Maybe if you have a fire alarm, then 30 seconds is not a good idea. So then it could be set to 0. But anyway, I can put it in again and it's not visible. Then the acknowledge and reset pins, they are necessary only in case you have a manual acknowledge and reset of alarms, like a button on a switchboard. Because normally, or you can have two ways how to acknowledge and reset an alarm. Either you do it through an HMI, like SCADA or display on the controller, or web interface, terminal, HT200, or whatever. If you do that, you don't have to keep these inputs out. But if you do want to reset or acknowledge your alarms by pushing of the hardware button coming from a physical input of the PLC, of course you have to have these buttons, these inputs out, and brought them to the input for acknowledging and resetting. I think that there is a nice help here for the single alarm memory with delay. No, it's not. Let's go for the outputs. The alarm status, this is actually an integer, and it tells us one of the 5 states the alarm may be in. So normally it's 0 and it's normal, no alarm present. Then if the raising edge comes on the in input and the time delay expires, then the block is in alarm, which means that is active. Then there may be 2 issues. Either the reason is going out again, so there is a falling edge at the input, but the alarm has not been acknowledged, which means that the users actually may not know about it, or the reason is still active, so the input is in true, and somebody acknowledges the alarm, which means that they say, okay, I know about this, I've suppressed a pop-up window or something, and this information was brought down to this block, which may act accordingly. For example, do something in the technology. Then, if the alarm is acknowledged, you will see the logical true at this output. Then the alarm reason has to be put away, like fix the fan or get out the water from the plant or something. And then the alarm can be reset, which means that it goes back to normal and the memory signal is going to false and the alarm is back in normal state again. Well, how to do it in RcWare? For this, we have a special alarm script here. We can take it from another project, like from the sample project, I think, Merbon SCADA demo. Let's have a look if there's an alarm here. It is, just this one. So you can see that it is a script data point. If we unlock the data file and have a look inside, we see that it has, let's say, more properties than a regular analog data point, for example. It has some multi-state behavior, so it can be in alarm, acknowledged, in memory, acknowledged but still in memory, and normal, like OK. And there is also some activity which is carried out after you click a button, because there are 2 buttons. One of them is called acknowledge and the other reset. You can see that the texts have been changed to confirm and delete. Like confirm is for acknowledge and delete is for reset. And what else? Yes, the scripts themselves. So now this is happening. This happens if you acknowledge the alarm.
And for this script, it is needed this function. You can see process alarm, and this function needs to be specified for every data file, which you can find here in running mode. And there is edit event handlers. And there is this script. This script defines our function process alarm, where are 5 states of alarm, as John previously told, like ACMEM, active and in memory.
Acknowledged, memory.
Acknowledged in memory, only in memory, and so on. And if you want this script to use our data points like this, just write us to support.domat.cz. We will send you the project from which you can take this data point and use it in your projects.
Mm-hmm. So in fact, it looks like that. I will steal or copy the text from this part, Control C, go to another window, to my project, open this, this global type definition and put Control V here. Now I go back again, check the data point with this alarm, this T, Control C for copy.
And it's important to remember that you need to have your project locked when you want to copy data points from.
Unlocked.
Yeah, you need the icon of lock to be active.
to be unlocked. Yes. Because otherwise you just operate the table and don't edit.
And I think it's needed to in both projects to have this icon active.
Correct. So now I click Control V, and here is my alarm data point. And the only thing I need to do here is to assign the data point here, right?
Data address.
Data address. This is what I do here.
Mm-hmm.
So in my project, there might be some alarm data point.
Mm-hmm. But what is the name of the...
Maybe here. This is an example of a kind of structured software where we have the handling unit fan block with alarm,
which we can find.
Which we cannot find here in the data point list. And I will have a look in the meantime, but so we have to select the alarm status data point always, yeah. But also for the other ones, this must be the acknowledge and reset data point. So this was alarm filter supply. The other one was acknowledged.
This one. Under one more. Not
and this one. Yeah.
Sorry. It is with the SW.
SW software acknowledge in. Okay. And the other one will be software reset.
Also with a software.
Software reset in.
Yes.
Normally, if we import it in the mass way, it's done easier. But now we have mapped an alarm block to the real alarm, which is in the PLC. We can try together with the alarm, which is now okay. Yeah. So if we have the hardware means to invoke the alarm right now, we could see how it can be acknowledged and deleted. But this has to be tested on a real PLC.
Or we can do it by debugging.
We can do it by debug mode in case we are lucky enough to locate this very one. Yeah, because we don't know in which handling unit it was.
Now, John created nice data point table, and I will use this table to create a technological scheme of this project. So I will stop the communication first. And when you want to create new technological scheme, you will find it in the setting tab. And there is create new sorry, not this one, but this one, new technology scheme. Our project, my project. And now the editor will open. You can edit your resolution of your scheme. So let's say I want it in full HD. So it is this resolution. And there you can find some basic settings for your scheme. For example, background color. You can use different one if you don't like the default gray color. For example, this. And let's start with creating some basic objects. The first object which you can add is text. It is just a simple text which you can put here. And in our case, we would like to try to change some values of data points. So I will write, for example, manual value change. You can center your text or align it vertically or put it into center. And also you can check this option. With that you can edit the text. Okay, this is not too nice. So I will center this vertically. And because I don't like the gray color here, I can also do the background color different. For example, this one, or I can use, sorry, I'd like to use white color. Maybe I'd like to have a bold. Okay, this looks better. Now we have first button. Within this button, we will manually set the value of one of data point, and I will use which data point would be great to use.
Well, it must be, no, these are measure values. So we have to use either the software reset or this set point above. But this is an analog data point, so we have to use not the button object, but the value indicator with the buttons enabled. Show value and buttons, which have to be somehow oriented. These are just buttons, but we also want to see the value. So just either we can add another object which is a value indicator and just select the value of this data point, show value, yes, and just OK. Okay, and we have to assign this value to this changing object as well. But this is already done. Okay, very good. Yeah. So what we also can do is to make a combine object which controls a value and displays it at the same time, which can be done just by showing value here. So now maybe it will be better to have the buttons down there, which can be horizontal button changed here by the buttons position. So now this looks better. Most of the time there will be two different objects, one of them for value indication and the other for the setting itself. So if we won't show the value, we can make something like that. And this also will be part of the SCADA scheme later. The scheme which we could see in the sample project, for example. As we said in the beginning, this looks maybe quite good, quite nice. But if I unlock the scheme, I see that this is the communicated value, and the rest is the bitmap. And these bitmaps are part of the libraries which we can see or copy from the sample project which we sent to you. Or it can be used as a background picture like this, because I have a background picture of boilers which can be shown, and if I don't show it, this is what's the rest of the page. So all these objects are manually inserted, like bitmaps or value indicators or animations, or maybe some setters which I cannot see right now, jump buttons to another schemas. Let's go back to our test project. Just shut this down. We haven't saved the page yet, so just close this small window. Yes, no. And this has to be saved. So the schemas are saved in the same folder as the rest of the data, like the project folder, together with the data table and all that stuff. And we can give it a name. So now the first panel is called schema. Okay.
Okay.
Now, if we want to add more pictures, we can do that.
And I will choose some of our library. But it would be good to set this picture, for example, to button. When you click on this handle, you can, for example, edit a value like this. So I am gonna do this. I will add object, value indicator. There is
So if you want to change the layout of the editor, like minus, plus, and init, it must be done in the data file, because now it only copies this layout which is in this table. If we want, for example, only the init button, we just have to remove the first two buttons. We see at interfaces 9, 10, and 11 the three buttons. And if you select the button position and make not none, which is up there, yes, the button is gone, and we only have this init button left. So now in the SCADA, there will be only the button. Now it seems that it's good to restart the PLC, the RcWare. This can be shut down. We see what's left. So we can see that there is just the init file, init button, and if we click it, or we can resize it, and this is the data point address of the set point, which is correct. And now the only thing we can do is to change the size, I think.
And can we add a picture for this button?
I don't think so.
So we need to add different.
But the button, this is just the button which changes the binary value of the data point. So I think that to change an analog value, there must be this init button, like invisible, and over this some kind of icon or so. But let's focus on the value indicators, for example. There is a value indicator, and you can make another value indicator of a temperature or so, or the schedule and that kind of stuff.
So this is how you connect data points with objects in scheme. Now I'm gonna add a time program, which is our schedule.
Yep. Show us button. That's a good idea. With a text like schedule 1 or time program. That's correct.
It would be great to set a picture here.
Picture. There was a resize property. General properties. And So this will be the time scheduler. Teď už to asi vyexportujeme, že máme 15 minut.
And also, if you want to add alarm, it is needed to make animation. We have this alarm script, and there are several states of alarm. As John told you, it is possible to have 5 states, and these 2 are not states. This is confirm button and delete button, like confirm alarm, of course, and you can restart the alarm. So after clicking on delete button, you will have OK state of alarm. And how to do the animation? It's maybe more complex from the beginning. You need to first choose your data point, which is the script in this case. And you can add multiple data points, multiple alarm scripts, but we will cover in this video only the basic. So there you can see all states which are defined in interface of the script. I can show you even just to make a better image. And you can see that interface number 3 has alarm and so on. So these are the states defined in the parameters of animation. And for each state, you need to put an image. I will simply show you how it is done. You need to add manually one phase. This is the first phase for which you specify the name of the phase of the animation. And here we add a picture. And you will continue like this for each phase. I will just copy this animation from another project.
Which is also possible and may save your time.
As you can see in this project, there is also alarm script which we use in our company, and for each state there is one specific image. If it's alarm OK, it will display this green image and so on. And there is the main part of the script which controls the animation, and it is this. The script is executed sequentially from above to bottom. So if the first line is true, it will go down and so on until the end. And this final column, this final row, it means when is there 1, so every other state which is possible in animation is equal to P4.
Okay.
And P4 here is defined as OK. And OK is interface 7, I think, yes, where is OK defined. So for the end of this script of animation, you can do more complex conditions. For example, this one, and there is A4 and A3, and it means that alarm is active and also acknowledged. So it will generate the first phase. It will connect with the first phase, which is called active and acknowledge. And for this state, we have defined this nice image. So this is how it works. If you have any questions to this, you can simply ask, but we have only 10 minutes left. And so I'd like to show you how to export this project to Merbon SCADA. We'll switch the project. It's not looking so nice, but for our purpose for today, it's gonna be enough. And when you want to export your scheme with data point table, you need to go in settings and click on export to SCADA 2. Because this is a newer version of RcWare, there are these tabs which are sorted now. It is not in one window with a lot of options to set. Now it is more
Structurized.
yes, structurized, thanks. And I'd like to show you some of the basics which you need to understand when you export your project to Merbon SCADA. So this is the path where is your project exported. It should be in Vision data file, and you can choose whatever name you want. I have RC export. Also, you can have only Vision data folder, but I will show you why I have this sorting, this saving. Not only why why it's not in only Vision data. Why I use this? It's because in this file, folder, is a folder called SCADA, which is the SCADA software, SCADA server.
The live project.
The live project, which is on the server. For example, it reads files from this folder. There you have projects, and these folders are called by GUID of project, which we can find out in RcWare. In edit mode, and it is here. It is the station GUID. Because we haven't exported this project yet, it will show to us later. So back to export. And sorry, back to the topic, why I have this, why it is good to have another folder for exporting is because when you export your project, it will create new configuration files here. And there, all your projects are defined. There are some configurations belonging to it. And if you have one specific like solution, like more projects on SCADA server which are running, it is needed to have all these projects specified in these configuration files. So when I export project from RcWare, I will export it to this folder, and then I can simply transfer the project with configuration file, if I want, to the SCADA server. So my settings will be kept. All right, so these are not important for us today, the other settings. But what is important is to have this option set. It means that the SCADA server, the project will start up when the SCADA server is online. And when I have this, I can export our station, which is called my project. It takes a while. In this case, not that much time. And in this folder, I have the project exported. As I can see, in the project config file, there is the project with the GUID, which I showed you previously, before. And there are some groups for
user access rights.
Yes. Also, this configuration file, it tells you, this is very important, as I told about I will show you, it's better.
The automatic execution.
Yes.
Yes.
It's this option.
Because if it's not checked, your project will be exported, uploaded to the server and all that stuff. But after you run the Merbon SCADA server and have a look into the project, there will be no live data, which means that the project hasn't started. And this makes the project to start at each startup of the SCADA server.
Yes, and if it is unchecked, this row will not appear here. Okay, so what I do, I want to take these two folders, CFG and projects, and put it into Vision Data, SCADA, and paste it here. What is needed is to restart Merbon SCADA server. You can press logo of Windows plus R, which is run, and then write services.msc. Just type M and find Merbon SCADA. Click on Restart. And now we should be able to see our project when I update.
So let's log in again into the server. And my project is there.
Yes, and we can see our
beautiful scheme. Unfortunately, no communication with the runtime because the 20 minutes are over. So if we restart the Merbon runtime again, it may take some time to refresh.
And this icon
this is now. So if we click the init, we can change the value like 50, and it should appear up there in the windows. Wow. There are some more bugs here, but this is just because the data we are working on are not alive, and it should be always taken from a real PLC.
All right. So thank you for your attention.
That was all we wanted to show you today, and see you again at one of the next tutorials. And if you have any question, let us know in the chat or just drop a mail to support@domat.cz.
Okay.
Have a nice day.
Bye-bye.